This lab tutorial presentation is going to cover primarily mover subclassing. As Rocco mentioned, movers are really fundamental to how Rosetta works. And so it's important that when you subclass a mover, that you make sure you get all the details in, particularly things like he said about making your mover work in C++, PyRosetta, and Rosetta scripts. So just to kind of recap what you've done before, this is one of those labs that will follow directly after. You've already, you've been working with Git, you've loaded a PDB into a pose, you've got a Monte Carlo loop going, you've packed and minimized, and you either have or you will be analyzing your acceptance rates and creating a really complicated full tree based on secondary structure. And now you've got all this code and you have it in your pilot app. But the way you should be writing a pilot app is, as Rocco described, using the JobDistributor. In order for that to happen, you have to basically move all your code into a mover and implement it there so that you can pass your mover to the JobDistributor. And so hopefully this will help you. I'm going to go through kind of step by step all the important things you need to mention. A lot of this will overlap actually with what Rocco said, which hopefully will be a good thing. And we're going to cover how to actually do the subclassing of mover. Then you're going to, on your own, be updating your pilot app to use the JobDistributor using your new mover. And then you're going to connect your mover to the MoverFactory, and I'll do some review again about how to do that. Make sure you have all your private data member in your mover, and then we're going to hook your mover into Rosetta scripts, kind of this last stuff that Rocco was talking about. Right. Okay, so first of all, I talked about classes in the very first lecture, and then Rebecca talked about it more. But there are additional things about classes that we need to know specifically for Rosetta. So in Rosetta, we have certain conventions that apply to classes. You've already heard some of these. Some of these might be new, but in any case, it's good to review. For one, they should be named in camel case. That's just a stylistic convention. We require that all namespaces match the directory hierarchy. You should know that by now, like protocols, simple moves. That the directory should also correspond to protocols, : simple moves for the namespace. Every class, you've heard this before too, requires 3 files. You need to have a forward header file, a header file, and a source file, the CSV file. So anytime you create a new class, it should have 3 files for it. Now I really shouldn't say every, I should say most. There are some exceptions to that, but for the most part, you should have 3 files. Header files have to have include guards. That includes the forward header and the header file. You've probably seen these before, but I'll go into detail about what they are in a little bit. And remember, you must not have public data. We don't allow public data in Rosetta. And then finally, if you're going to have any owning pointers or APs, and you almost certainly should have some OPs, your class needs to inherit from reference count. It doesn't have to be directly. It could be through something else, but it has to, as you go all the way up, you should eventually get to a reference count. Okay, so I'm going to go through kind of line by line, but a little quickly. Every forward header that you have, and every file in Rosetta has got to have the copyright info. Okay, so you've seen that before. We'll jump up a little further. And then, I don't know if you've started noticing this in a lot of files, there are these doxygen comments. This is how we document our code. There's a script, a doxygen script that goes through and automates this stuff. So your forward header should say its file name, and the notation is you have a little @ symbol and then the word file, and that's the name of the file. All files in Rosetta should have that. All files in Rosetta should have a brief statement that tells you what the file does. It doesn't tell you what the class does, it tells you what the file does. And then your name and hopefully your email address so people can send you nasty emails if you've broken their code or something. All right, so we're talking about the forward header file, the fwd.hh file. So this is what we mean when we say an include guard. So this is a preprocessor directive, starts with a symbol, a pound symbol. And this is just saying if this macro is not already defined, then define it. So our coding conventions are that we say in big letters, included, protocol, simple moves, the namespace, the name of our class, and then forward header. And then at the very end of the file, which you'll see in a second, it'll say end if. And so that means that this will not get read more than once. So you should include that kind of thing at the top of every file. Then you include your headers. You already know that. So forward headers, the only real include that you really need to have in your forward header is owning pointer.hh, and that's only if you're creating OPs, which you mostly will be doing. And that gives you the code for owning pointer here, so this makes sense. Then you need to have your namespace. You've seen that before. Now you finally declare your class. This is a primary thing that a forward header does. It just says, I'm going to be later on defining a class called sample mover. Then finally, you have to talk about your type defs for your only pointers. And I think Andrew covered this before, that we do this. And if you want to have access pointers, you have similar lines below that would have access pointers instead of owning pointers. Same idea, and you call them APs instead of OPs. So that's kind of what a forward header looks like. It's a pretty short file, but it's important to have it. All right, so let's jump over now to our header file. This is the .hh file. Like every other file, you should have your copyright and your document information, so I'll skip through that. And then you go to your headers. So here, the headers, you have a lot more of them because you have a lot more code that you're going to be using in the header file. And I want to point out that for the most part, a header file should include forward headers, not regular headers. The exceptions are core types. This is that file that includes things like core size, core real, a lot of the shortcut type defs. Things like IDs. And then it's important that you have to have the header file, not the forward header file, if you're inheriting from something. So since this whole tutorial is about subclassing movers, you're going to inherit from mover in any of your submovers, and so you need to have the mover.hh and not the forward header. But for the most part, you should always have forward headers. So that's the headers. Then we have the namespacing, and then after the namespace, we do our definition of our class. So here we go, class sample mover, like in my first lecture, and you've seen it before, this colon means it inherits from whatever's over here. So we're publicly inheriting from our mover, so that lives in moves. Protocols, yes. Yeah, single colon after a class definition is where you say what you're inheriting. Yep. Inheriting from. Yep. So sample mover inherits from mover. And mover lives in protocols moves, but since we're already in the protocols namespace, you can just say moves. So that's going to be key to any move you're making. All right. Then after that, the next thing you want to do is you want to do what I call the standard methods. Some people call these boilerplate methods. But that's the things like the constructor, the destructor, the assignment operator, and the copy constructors, things that are kind of fundamental to almost all classes. And so you would declare them all here. So here's our, this is just the regular empty constructor. Here's a copy constructor. Sometimes instead of object of copy, people have RHS, which stands for right-hand side. But it doesn't really matter as long as you have the name there. Here's a different constructor that's overloaded so that you can pass in a move map. And this goes back to what Rocco was just saying. If you want to try to think ahead and think, how will people want to use my mover? And so if there's certain settings that people will want to change on a regular basis, like a move map or something else that you might be able to come up with that that's specific to your mover, then you would probably want to create a bunch of extra constructors where you can construct it with those initialized variables right from the start. So it's really handy to create a bunch of these in a helpful way. Now, you haven't learned about overloading overloading operators yet. We'll learn about that later. But when you've learned about that, go back to this slide, and this will make sense. Then we have a destructor, which you have learned about. So all those things need to be there. Now we're going to get into some virtual methods. You'll see a lot of virtuals down through here. And just as a reminder, in my very first lecture, we talked about subclassing in general, and we had our little cat analogy. And I point out that when you use a virtual keyword, that means that this method can be overwritten. If it actually says equals 0, it's a pure virtual, and it has to be overwritten or implemented. There is no implementation for make sound in the base class cat. Every cat has to implement that method, or it won't work. However, for eating food, that's an optional. You can have it eat food the default way, or you can eat food in a special way. All right, so going back to mover, what we're talking about now, there are two pure virtual methods in mover. So if you open up the mover.hh file, you'll see these lines. Apply is pure virtual. Rocco had just stated that. The only other pure virtual in there is getName. You are required to implement getName in your subclass mover. The rest of these, and there's actually some more, are virtual but not pure virtual. They may be overridden in your mover class. Most likely they should be. Like for example, show. If you don't override show, the default show is just going to say, when you print a mover out or you output a mover, it'll just say, I am such and such a mover, and that's it. And there's it doesn't really do much more than that. But it'd be really nice for all movers to have a show method that actually said what their private, display some of their private data. Like I'm a mover, I'm set up to do this with this move map, etc. That's really helpful. So it's good to do for people to debug, or for anyone using Rosetta, it's good to implement show. Similarly, if you don't have to implement parse my tag, but if you don't, you mean nobody can use your mover in Rosetta scripts. So you should definitely go through and implement parse my tag. When you're creating your mover for during this next lab, pop open mover.hh and look through these methods and see what you should be implementing or what you shouldn't. But the top two you have to implement. All right, so we're going back to our header example file here for sample mover. So again, here's the clone and fresh instance, which Rocco told you how to do with Rosetta scripts, get name that you have to implement, etc. And then there's apply. Okay, after that, we go to our accessors and mutators. Again, for ease of use for people using Rosetta in C++, or for people using it in Rosetta, it's nice to be able to look at what move map is actually stored in this mover, for example. So here's a getter. This returns a constant owning pointer to move map, and the function is const, which means you can't change the move map, you can only look at it. And then here you can set the move map in this case. So you add setters and getters as you see appropriate to access the private data. And then finally, you have private methods. Now, you don't have to have these. This will depend entirely on your personal coding preference and how you're coding, but private methods are a nice place to put chunks of code that are kind of nice little subunits. Like for me personally, I like to use an initialization subroutine so that all my constructors can call one single subroutine to initialize all my variables. I also like to have a copy data subroutine so that my copy constructor and my equals operator can also call the same subroutine. It makes the code a lot more concise. And then finally, like in this imaginary sample one, I just have this thing that sets up a residue list. You can have anything you want in here for private methods, but I don't want people just calling this stuff. This is only for the mover to use when it's doing its apply stuff. And then finally, we get to private data. Here's where you store things that you need for your mover to do when it's applying its move to the pose. So in this example, we want to store move map here, or maybe we have a list of residues that are movable. And so that's kind of it. Now, one more thing is this insertion operator. Again, you'll learn more about how to overload operators later. But when you do, go back to this slide, and it's really helpful if you have this operator overloaded so that it calls a show method. If you do that, you can just say cout and then pipe the name of you just pipe your mover, and it will output a bunch of information that's helpful about your mover. It's really handy for debugging purposes. Anyhow, that's kind of like a quick flow through what your header file should look like when you're done this assignment. And then as far as the implementation file, that is pretty straightforward. Okay, so we just talked about how to create a new mover subclass. After that, you'll go through the lab and you'll update your pilot application so it uses JobDistributor with your new mover. Then you have to connect it to the MoverFactory. And so I'll briefly go into that again. Rocco already introduced this topic, so a lot of this will just be overlap. But a mover creator's methods that's on the next slide, sorry. One interesting thing about our coding conventions here is that this is one of those kind of exceptions. A mover creator is a class. However, you declare a mover creator in its own header file, like say sample mover creator.hh, but then you implement all the mover's functions in the CC file of the mover itself. So if I have a sample mover, I'll have a sample mover creator.hh, but I'll define all of the functions in the mover.cc file. Okay, it's just a kind of a convention that we have. So this is an example header file for our sample mover. You need to have your include guards just like normal. Again, you need to include what you are inheriting from. And then down here, you see that I'm creating a sample mover creator, and it's inheriting from public moves mover creator. It only has 3 methods, and Rocco already talked about these. You need to have a create mover, you need to have key name, you need to have mover name as functions. So that will be in every one of these mover creators. To implement them is really simple, and again, Rocco already sort of talked about that. In the mover.cc file, you should have these lines where you have sample mover creator key name. All that's going to do is return the mover name of that mover, which is down here. And then you're going to have create mover, which will just simply return a new sample mover. And that's that. Yes?
The question that the approach you can talk before, but if you inherit without specifying public from another class, does it do by default public, or does it also somehow public private?
I don't know. Do you know?
My guess is that public is the default.
Okay.
Okay. Does it, is it possible to inherit private?
Yes. But you usually don't want to do that. That will mean that everything that was public in the parent mover is now private, and so nothing else can call it. Nothing. So if mover, for example, if you inherited from mover privately, all of the public methods that were in mover would appear as private in the subclass mover, so that nothing but that subclass mover would be able to call those. Right. Okay. So now we've made our mover creator, which is really quite simple to do, but we need to register it with MoverFactory. Rocco already told you how to do this. I'll just repeat it again real quick. You just need to make sure you put a pound include with the name of your header file for your sample mover creator and just add it to this file. You'll see that that file is just entirely headers of other mover creators, so it's really easy. And then you need to register your mover creator with the MoverFactory, and the way you do that, like he already said, is to add a line that looks like this. It's static, it's a mover registrator class, it's templated, so you put the name of your new mover creator in there, and you just give it a name. You can make any name you want, but the convention is to use REG for register underscore name your mover. So 2 things to add to 2 different files, and now once you do that, anyone can request an instance of your sample mover from the MoverFactory. And he showed you how to do that, and this is just it being repeated. So because it's singleton, you have to get an instance of it, and then you call that instance's function. This violates the coding conventions, but that's just the way it is. You remember, function should always be boxcar, not like that. Okay, now we've got our MoverFactory can now create our mover for us. So the last thing that the lab is going to have you do is to hook this into Rosetta scripts so you can use Rosetta scripts to access your mover. And Rocco also talked about this and did a good job at that, so this will be pretty quick. Whoops, not that quick though. All right, so I also wanted to talk about PyRosetta before I got to that. So to use a mover with PyRosetta is to set it up so that other people can use it is a lot quicker and easier. There's just 2 main things you need to remember. One is if you define something in your header file, you have to declare it in the CC file. Now C++ will let you declare things and then not do anything with them, but if you don't define your methods that you declare, PyRosetta freaks out when Sergey tries to compile it. So make sure you don't declare something and then forget to define it. The other thing was talked about earlier today when Andrew was talking about const, and make sure you don't declare any parameters that are passed by value as const in your declaration. And then if you do those 2 things, everything should work for PyRosetta out of the box. It's really nice. And Rosetta script's a little more complicated. This is what Rocco talked about, and that is that you need to make sure you implement parse my tag. So this is just an example for our little sample mover here. Let's say it had some private data, number of foods, and there was some tag in Rosetta scripts that had number of foods. Then you can just down here in parse my tag say tag get options, and it's going to be a size, number of foods, and the default value is 1. And then for something more complicated like the move map, the move map comes from a different Rosetta scripts tag, and fortunately the Rosetta scripts namespace includes some handy parsing functions that are already there for you. You don't have to do the work. So you just call this protocols Rosetta scripts parse move map, and you give it the tag, you give it a pose, you create a new move map for it, like I do right here, you pass that in. It's going to modify the move map based on the information from the XML tags, and then you just set your move map right here. And so you can do things similar to that in your code when you're parsing my tag. So that's kind of it. And you do all those things, and you've just made your mover work with all 3 interfaces. So it's really handy. So that's just the introduction to the lab. And hopefully you can go back to these slides and it'll help with you as you're trying to go through the procedure. Any questions?